All right, algebra 1. Here we go. Ready? Let's see if this works. See, it'll work. All right, it works. The highlight. So, graph interpretation word problems, average rate of change graphs and tables, average rate of change word problems, quadratics. This makes me think of my song Word Problems. All right, so let's get started. Units and quantities, that is what we always want to look at first. So looking at this graph, I see E of C and C. I'm wondering what C represents. Maybe I should read the question. The efficiency of a motor can be measured by the percentage of the input power that the motor uses. All right, power, percentage of input power. E of C models the efficiency in percentage points of a certain motor as a function of the power's input current. Okay, so we're talking about putting a current into a motor and then the efficiency of that current measured in percentage points. So do we have a graph? Oh, okay. So we can see, just to understand this, we're putting some power, some electricity into a motor, and it doesn't do anything. And then all of a sudden, at this current level, it goes, whoa! And then it works really good, percentage-wise. You know, there's a lot of efficiency. And then the efficiency starts to go down until a current of 3, it's 0. So it means, you know, there's a certain level of current that we want to put into the motor, and it's not just more current the better, as the graph clearly states. So this is the interesting thing. The x-intercept. The motor loses all its efficiency. I would say that is what happened. That's the x-intercept. The relative maximum right here, it's when it's most efficient, right? Most efficient. There we go. 50%. Yeah. All right. Increasing or decreasing as the input's power grows beyond, the motor becomes less efficient. There we go. You guys want to do another one? Let's do one more. All right. In altitude. So, but I want you to notice that I didn't just try to answer the question. I looked at the units and I tried to make sense of the graph on my own and understand what it was saying. If you don't understand what the graph is saying, then you should put this in the red section of the organizer, not just try to mix and match until you get it right and think that you know it. Of course, I don't think you're doing that, although some of you might be. Don't do that. The altitude of a tree affects, hey, let's look at the graph. I like looking at the graph and then reading about it. Like that. I'm excited to read what I was reading. So I have A, I have G of A, and it's going up and then it's coming down. So what does A represent? The altitude, oh, okay, of a tree affects the rate at which the tree grows. G of A models the growth rate. Okay, so G of A is a growth rate in millimeters of a certain kind of tree, A kilometers above sea level. So the higher the tree is on the earth, affects its growth rate. Does it make it grow more or less? Well, we can look at our graph and find out. So the altitude is right here. And the growth rate is right here. So this is the altitude. Usually we think altitude is like up, but anyway. So at altitude of 0, it grows at 1.4. As the altitude increases, the x values get higher. As that happens, the y value gets higher too. The tree grows even faster at higher altitudes until you get to a certain altitude, like 8. And then after 8, the tree starts to grow slower again. You see, so we've made sense of this problem. The tree is growing at a certain pace. It gets higher up on the earth and it grows faster. Then after a certain point, it starts growing slower again. So what is the y-intercept? The y-intercept is when x equals 0. And we know that the x's are the altitude. And so we know that 0 degrees is sea level. Does it say that? Or do I just know that? Above sea level. So 0 would be sea level. So where does it say sea level? Sea level. Sea level there. Relative max or min. So that happens, the maximums here is about 7 or 8 or something. And that is the maximum height of the tree. The fastest possible growth rate. Maximum growth rate of the tree. And increasing or decreasing. Yes. All right, so that's enough of that. You can ask questions about that. All right, now average rate of change graphs and tables. Over which interval does it have a negative average rate of change? So, what the average rate of change is, you can write down that and then just write slope. So the average rate of change is simply a slope between two x values and their corresponding y values. So if I pick this point here, and then I pick this point here, what's the average rate of change? Well, all I got to do is, it's the slope of the line between those 2 points. That's all it is. And, we can see that the actual function goes up and down and up. So an average is just a generalization. So they're going to give us some x values, and we're going to find the y values on the graph, and we're going to calculate a slope. If the slope is negative, we will select that answer because they're looking for a negative average rate of change. So 3 and 5 are the first x values we can choose. So where's 3? 3 is right here. I see the point 3, 3. 5 is right here. I see the point 5, 3. Well, I can already tell they're both at a y value of 3. That slope is 0. I'm not even going to calculate it. -9, -8. What about that? -9, -8. And the nice thing is, we don't actually have to calculate the slope because I know that that would be a positive slope because the line that I just drew has a positive slope. Gotta be this last one then, huh? -9 and -3. -9 and -3. Well, this is positive again. That's positive. Okay. 3 and 8. Come on, 3 and 8. You gotta have a negative slope. So 3 is right here again. And 8, look at that. A negative slope. Look at that. Negative sloping line. So the interval between 3 and 8, as you can clearly see, has a line that has a negative slope. And I didn't even have to use the slope formula. Average rate of change. Oh, you know what? This said tables and graphs. But hey, this is going to be the same thing. This time they give us a table and they give us some x values, but we can use the table to get the y value. And we are going to have to use the slope formula this time, but that's not a problem. So what's the y value for -3? It's 6. So what's the y value for 1? It's 0. So I like to do like change in x change in y. So it's increasing by 4, decreasing by 6, rise over run. What's the average rate of change? Negative 6 over 4 or negative 3 over 2. Rise over negative 3 over 2. Come on. Yes, I got it. All right. Now on to the word problems. Is sitting on the beach, watching the tide go in and out. Wow, that sounds so nice. Uram's distance from the shoreline in meters as a function of time in hours is graphed. What is the approximate average rate of change at which Uram's distance from the shoreline increases between the 9th and the 13th hour marks? Okay, well, this is going to be really easy now that I just did the average rate of change graphs. So they gave me 9 and 13. Pause. All right, when your wife calls, you got to answer. That's the rule in the Field family, unless I'm working, with kids in front of me. Okay, so 9 and 13. Choose one answer. So we're just going to stop scrolling up and down, and we are going to put a mark at 9 and a mark at 13. And it said the approximate average rate of change, right? So it looks like 9 has a y value of 6 and 13 maybe 8. So what is the change in x? It looks like it's increasing by 4, and the y is increasing by 2. So 2 over 4 or 1 half or 0.5. So let's see, do any of our choices match 1/2 or 0.5? 0.75 is the closest one, and that's what we got. So my numbers might have been off, but I knew it wasn't more than 1. Okay, and there's a table. So this one, so you're just finding the slopes. They're giving you the x values, they give you the table, the y value is in the table or on the graph, and then you calculate the slope. And in this case, you'd compare. All right, so that's that. Now, with these quadratics, I am not going to go through and do the whole quiz for you, but I encourage you, to try it and to go, well, you have to try it, but you need to go back to the organizer and look at your posts and make sure you updated them too, right? But I want you to look at your old posts and then try, or at least try it, and then look at your posts. In any case, do both things because they're both powerful learning strategies, right? So, and of course, post in the organizer in the news section for this week, and then ask your questions in class, and I'll see you there.